In our previous lessons, we were looking at solving linear equations and looking at the graphical representation to verify solutions. And we can always still refer back to the graphical representation, how the lines are intersecting to do that. But we're going to try to stick with more of the algebraic means as we're doing things today. So again, you do have your links here on your slides to get you going for the calculators if you need it. Otherwise, you've got your multiplication table to use as well. So here's our first example. It says, Donald tried solving an equation. Unfortunately, the solution is incorrect. Based on your understanding of solving equations, please tell Donald which line he made his error. So you have your 3 lines to the problem. Figure out which one has the error, and can you show the correct way to arrive at the solution. So as we look at Donald's steps, we can see that there was an error made on line 2. He incorrectly combined unlike terms. 7 and negative 3x are not alike, therefore we cannot put them together. What should have Donald done? Well, we should have had him subtract 7 from each side of the equation. Therefore, now we have negative 3x equaling 5. Then we have to undo that multiplication of negative 3 by dividing each side by negative 3. Therefore, that leaves us with x equals negative 5/3. Now, if you wanted to check graphically if this is the correct solution, in one of our lines, we would graph 7 minus 3x. The other line we would graph as 12, and when we see where they intersect, it would be at this value. Now, if you're thinking about the decimal approximation, this is a negative 1.6 repeating, so negative 1 2/3, and you can use that also to help you. But leaving it as the exact value is also useful. Now, Donald tried another, and unfortunately, he still made errors. Could you tell him which line has the error, and then correct it to demonstrate the correct solution? In this problem, the error occurred in line 2. Right here, when Donald distributed the negative 3x, he did it properly here, negative 3 to x, I should say, but not the negative 3 times the negative 6. That should be a positive 18. So this is what line 2 should have looked like. Now we've got some simplifying to do on the left-hand side. We're going to combine our like terms. We'll have 2x plus 18 equaling 2. To undo that addition of 18, we're now going to subtract 18 from each side, giving us 2x equals negative 16. Here we'll divide each side by 2, and our final result for x should be negative 8. And again, graphically, if you want to check your solution here, you can go back to the original equation and put the left side into the y1, the right side into y2, and see where they meet. The x value of that coordinate would be negative 8. Now, if you wanted to do an algebraic check like we talked about yesterday, you could take negative 8 and substitute it back into the original problem for x and simplify it. If you've done all the simplifying and solving correctly, you should get a 2 equals 2 to show that you're on target. Let's try a few more solving equations before you do some practice on your own. So here we have 1/3 times the quantity x plus 9 equaling negative 12. You want to ask yourself what needs your attention first. And here your eyes might be drawn to that 1/3. Now, that fraction, remember, that means it's a division problem. You are dividing by 3. So how do you undo that? You can multiply by 3. So your first step, you could choose to multiply the entire equation by 3 to undo that division. Well, what will happen? 3 times 1/3, that's 3 over 3, 1. That undoes that piece. Then you take 3 times a negative 12, and you get your negative 36. Okay? So now we're just left with x plus 9 equals negative 36. We have to undo the addition of 9, so we could subtract 9 and get our value for x, being negative 45. So again, if we graph the equation on the left and graph the equation on the right, where they meet, they would have an x value of negative 45. Or if you want to check by substitution, put the negative 45 in place of x, work out according to your order of operations, you should get negative 12 equaling negative 12. Now, if you didn't undo the division first, some of you might have said, well, let's distribute that 1/3 to our parentheses. And you can do that as well. It would look like this. You would have 1/3 x plus 9/3. And we know 9 and 3 have a common factor of 3 we can divide out, which brings you to here. You could subtract 3 from each side, and you still have to take care of that division by 3, so we would have to multiply both sides by 3, and see how you still get the final answer being your negative 45. So this one was a matter of preference. I would suggest undoing the division first and following through to solve for x, but if you choose to distribute, you'll still get the same result. Let's try another one. Here we have negative 3 times the quantity x minus 6 equals 66 minus 19x. How can we solve for x? So in order to undo this equation to solve for x, someone might have wanted to distribute the negative 3 to x and the negative 6. In doing so, you'll have negative 3x plus 18 equals 66 minus 19x. So we start with the lowest variable, which is negative 19x. We're going to undo that subtraction by addition. So we're going to add 19x to each side. That leaves us now with 16x plus 18 equaling 66. We have to undo the addition of 18, so we'll subtract 18 from each side of our equation, giving us 16x equals 48. We have to undo the multiplication of 16 by dividing each side by 16. That gives us 3. So again, a way to check your results, you could put the left-hand side of the equation, negative 3 times x minus 6, or if you want to put the simplified version, negative 3x plus 18 in your y1. Put the right-hand side into y2, 66 minus 19x. You can see where they cross, and the x value is 3. You could also take this value of 3 and substitute it into the original equation and make sure when you're doing your simplifying that you get the same value on each side of the equation. Let's try another one. Here we have 7 minus 6x minus 2x equals 4x minus 17. How can we undo the equation to solve for x? Well, as we look at this equation, we can see on the left-hand side, we have some like terms that we can combine. Negative 6x, negative 2x. Putting them together gives you negative 8x. You can also think of it on the number line. If you were at negative 6, you have to go 2 to the left of there. That brings you to negative 8. The left-hand side is simplified. The right-hand side is simplified. Now you go with the lowest variable. Our lowest variable is the negative 8x. So to undo that, we're going to add 8x to each side of our equation, giving us 7 equals 12x minus 17. We have to undo the subtraction of 17 by adding 17 to each side of our equation. That means on the left-hand side, we now have 24, and the right-hand side, we've got our 12x. Almost done isolating x. We have to undo the multiplication of 12, so we'll divide each side by 12, giving us 2. So again, how can you check and make sure that we are correct? Well, we could take the 2 and put it back into the original equation, right, and simplify. The left-hand side and the right-hand side should give us the same result. Or, using Desmos, we can put the left-hand side of the equation in y1, the right-hand side of the equation in y2, and see where they meet, and the x value should be at 2. So at this point, we're going to have you do the practice problems following that slide on your own. If you do need additional reinforcement, you do have on the last slide some more video links helping you solving equations algebraically. Remember, you have the links for the calculators on your slide 1 And the self-checking feature for Class Kick has been turned on, so as long as you're entering in your results correctly, you'll get your solid green outline. Remember at the top of your directions, it does remind you how to enter in your results. You can have them as x equals the value, no solution, or infinitely many solutions.